Good morning. Thank you for joining us for our water year 2024 early season water supply outlook. I'm Cody Mosier, a hydrologist at the Colorado Basin River Forecast Center. There's still some few people showing up, but we're going to go ahead and get started. So what we're going to chat about today, first look at a quick summary of water year 2023, and then jump right into observed precipitation during the monsoon season and into the beginning of water year 2024. Take a look at our soil moisture conditions from our hydrologic model entering the winter season. Look at current snowpack conditions. Provide a brief overview of our ensemble streamflow prediction water supply forecasting method. Look at some early season water supply model guidance for the upcoming or current water year. Take a look at upcoming weather and ENSO El Nino Southern Oscillation status, and then end by letting you know how you can get in touch with us and looking at the upcoming water supply briefing webinar schedule from the CBRFC. So I believe attendees are muted automatically, but we will open it up at the end for a Q&A session. You can also type in a question into the chat box or the question box within the GoToMeeting webinar. So real quick look at a summary of the water year, last water year 2023. So on the left, looking at April 1st, % of median model snow water equivalent. So again, SWE, snow water equivalent, the amount of water that's in the snow, and image on the left there broken into the three regions that we forecast for the Great Basin, Upper Colorado and Lower Colorado. Lots of blues and purples. It was a great snowpack year last year, typically above 200% of normal. Those purple colors showing that there were a few areas that didn't do as well, but generally pretty good year. So many basins had well above normal snowpack conditions and seasonal runoff that ranked in the top 5 dating back to 1991. So the big table on the right here, I'm not going to go through all these numbers. It's more for reference if you want to take a look later. And then some basins experienced record snowpack and seasonal runoff last water year. So a couple cases for basins or locations that had their wettest runoff season last year. McPhee Reservoir in the Dolores that ranked #1. A Little Colorado location ranked 1. You can see many of these areas, top 3, top 5 across the Great Basin. Top 5, Lower Colorado, generally top 5. There were a few areas like the Colorado headwaters above Kremling, down to Cameo, as well as above Fontenelle that didn't do quite as well. These are, you can see in the map here on the left, those some yellow and kind of lighter blue colors there, corresponding to those areas that were about the 10th wettest since 1991. Now into the 2023 monsoon season. So the monsoon season runs June 15th through the end of September. These graphics are showing the full June through September period precipitation in the upper left as a % of average, and the lower right as a percentile, with the browns indicating below normal precip during this period. So those areas that typically benefit from the monsoon season precipitation would be Arizona up into southwest Colorado. So those areas really didn't benefit from this past monsoon season. And in some cases, like the Phoenix area, it was actually the record driest monsoon season. So we went from very good snowpack runoff conditions into a very dry period. This green area here, if you remember, there was a hurricane or tropical storm Hillary mid-August that dumped a bunch of precipitation down into Southern California into Nevada, but really didn't see much precipitation where we would expect or hope to see that monsoon season precipitation keep flows higher during the summer. It was a pretty poor monsoon season overall, which gets us into our hydrologic model soil moisture conditions for this fall. So the graphic on the left showing our soil moisture conditions out of our hydrologic model as a percent of average. And this map is corresponding to the soil moisture content from the lower soil zone in our hydrologic model, which is typically correlated to previous year's runoff, summer fall precipitation, to name a few things there. And we do take a robust look at this every fall after the irrigation season ends and before winter sets in. So typically the first 2 weeks in November, we're taking a really close look at our hydrologic model soil moisture conditions and dialing them in. We're looking at everything from early November stream flow observations, reservoir inflows, that precipitation that occurred July through October, as well as the kind of runoff we saw the previous year. So how does soil moisture impact water supply runoff outlook? Above normal soil moisture conditions, those have a positive impact. So we would expect increased runoff efficiency for those areas with above normal soil moisture conditions, and vice versa. For a basin that has a below normal soil moisture conditions, we would expect decreased runoff efficiency or a negative impact on the water supply outlook there. So taking a look at the map across the Colorado River Basin, near to below normal soil moisture conditions. And if you just start in the lower Colorado down in Arizona, work your way north, soil moisture conditions improve. So below normal down in Arizona, southwest Colorado, closer to normal, west central, northwest Colorado, and then near to a little bit above normal in the upper green in southwest Wyoming. In the Great Basin, Utah area, so our model soil moisture conditions entering the winter season near to above normal. So not really surprising there, given you know how dry it turned after the runoff season. This corresponds fairly well to what happened, you know, June through October, roughly, precip-wise. When it comes to the timing and magnitude of the spring runoff, it's really a result of the snowpack conditions, how the spring weather plays out, and these soil moisture conditions. Taking another look at soil moisture conditions. So here we're comparing fall of 2023. So this year versus our model soil moisture conditions from last year, shown in the middle, and then the difference between the two. So the graphic on the right shows where soil moisture conditions are better. The green colors indicate better soil moisture conditions compared to a year ago, where the oranges show areas where soil moisture conditions are worse compared to a year ago, and then the gray areas plus or minus 10%, so right about the same that they were a year ago. So soil moisture conditions improved across Utah and southwest Wyoming, west central Colorado, kind of a mix of a little bit better or about the same. And then as you work your way south into southwest Colorado and Arizona, soil moisture conditions worse this year than they were a year ago. Here we're looking at the beginning of water year 2024, so the first 2 months, October and November, the precipitation as a percent of average. So it was a slow start in October and November, just a few areas receiving precipitation near to above normal. That's northern Utah, the very headwaters of the northern Green or the upper Green, and then west central Colorado, kind of above normal precipitation limited to those areas in October. November, most areas, the exception of this pocket in northeast Arizona that had above average precip, but overall slow start, below average start to water year 2024. And then the table on the right here is just the values associated with some subbasins. So above Lake Powell, first 2 months came in around 75% of average. So you can find your basin of interest there and see how the first 2 months of the water year came in terms of percent of average precipitation, generally below average. And then into December, so we have seen storm activity increase in December, especially across northern Utah into southwest Wyoming and western Colorado. So nice to see some increased precipitation start to take place in some areas. Again, fairly limited to those northern basins. And then the graphic on the right, this would be the water year to date, so October 1st through yesterday. So generally below to well below average precip conditions so far this water year. Again, the exceptions being some of those northern areas, the northern Great Basin, west central Colorado. So now into the snowpack conditions that are out there. The graphic on the left is showing the snowpack conditions as a percent of median with the squares representing NRCS SNOTEL stations that are on the ground out there, and the shaded areas would be our hydrologic model, those significant areas that contribute most to seasonal runoff volumes. So not shocking to see, those areas that saw some of the increased storm activity in December reporting better snowpack conditions than, say, southwest Colorado down in Arizona. And tabular format in the middle here, so above Lake Powell, about 75% of normal snowpack conditions as of yesterday. These values are from our hydrologic model. And then so upper Colorado River Basin, just to summarize here, generally near to well below normal across the upper Colorado River Basin. Current snowpack conditions. And the lower Colorado River Basin, they really haven't seen much snow at all, generally less than 30% of normal at this point. But the Great Basin, they have seen more storm activity than elsewhere, and they have the best snowpack conditions currently. 90 to 125. Generally, the exception is the severe. So severe virgin kind of down here in southwest Utah, that area not doing as well as northern Utah. Comparing our snowpack conditions now compared to where they were a year ago, so they are worse compared to last year. The graphic on the left showing December 12th, 2022 snowpack conditions from our model, and the graphic on the right would be this year. So off to a slower start than last year, snowpack wise. So now into our early season water supply model guidance. So at this point in time, Our model soil moisture and snow states are accurate and representative of current conditions. Again, we do spend a lot of time dialing in those soil moisture conditions and looking at our model snow states every week. So right now, soil moisture can also be thought of as base flow. It has a larger influence on the water supply guidance now compared to later in the season. And as we progress into the winter, snowpack conditions have a larger impact on the forecast, especially in the upper Colorado and Great Basins. Winter rain events, those typically have the largest impacts on the lower Colorado River Basin forecasts across Arizona, Southwest Utah. So our early season water supply forecast errors are generally 20 to 40% and improve through the spring as we have more information about how the winter is evolving. And the primary source of the forecast uncertainty is future weather. So what is the weather going to do the next 5 to 7 months? That's the biggest piece of forecast uncertainty. Mid-December snowpack conditions. So right now, about 30 to 35% of the snow season has occurred, and the normal snowpack values are still small compared to as we get further into the season. So our ESP or water supply guidance, it's more sensitive to snowpack conditions now compared to, say, on April 1st. So when we say ESP, what does that mean? ESP stands for Ensemble Stream Flow Prediction. That's the method that we use to produce our water supply forecasts. So this is showing how ESP works. So we're starting with our current model conditions. So that would be snowpack conditions, soil moisture conditions, and simulated flow. And we apply precipitation and temperature from each year during the 1991 through 2020 period. And for each one of those years, a forecast hydrograph or trace is generated. And then we take the results and we use those to produce a probabilistic water supply forecast. So this is an example of ESP for a particular location. So this is Blue Mesa Reservoir. This is in the Gunnison River Basin. So this is our hydrologic model run from yesterday. So down here on the graphic, starting December 12th, and you can see we passed through 1991 through 2020 weather. So precipitation and temperature through the model. And for each one of those years, we get a a flow for each one of those years, and we can sum those flows into volumes for the period of interest. That's typically April through July is the volume, the seasonal volume that we're forecasting. And from those 30 values, we can compute exceedance probabilities and come up with a probabilistic water supply forecast. So you can see the table in the middle here. We pick out, say 2002 was a very dry, low snowpack year. So if we were to see our current model soil moisture conditions now, and we experience the temperature and precipitation from 2002, we would come up with a volume of around 228 CAF, or 228,000 acre feet. You can compare that to 2019, which was a wetter year. That would be around 950,000 acre feet if we were to see the similar to weather to 2019. And you can break these down into, volumes that have an X% chance of being exceeded. So this is an example here. So 90% corresponding to the water supply forecast evolution plot in the lower right. So the 90% value 90% volume would be 376,000 acre feet. So this would be the volume that has a 90% chance of being exceeded, or a 10% chance of not being exceeded. And you can work your way up to the top. So the volume that has a 10% chance of occurring, this would correspond to a wetter future weather, wetter winter scenario. We would expect to see around 920,000 acre feet. So that would be the volume that has a 10% chance of being exceeded, or a 90% chance of not being exceeded. And then our official 50% forecast, generally used most often. So that would be the volume that has a 50% chance of being exceeded or not being exceeded. In this case, 546,000 acre feet. So that's the method, ESP, that we use to generate our water supply forecasts that are probabilistic. All right, so now this was our hydrologic model run, our ESP model run from yesterday. And this graphic is showing volumes and percentages compared to the 1991 through 2020 period. I'll just start in the Great Basin here. So we're seeing the best conditions in the Great Basin. Again, the soil moisture conditions are generally above normal, snowpack conditions near to above normal. So we would expect these basins to have better water supply conditions than elsewhere across our area. So a couple examples here, in the Woodruff Narrows in the Bear River Basin, forecasting or the latest ESP model guidance is right around 100% of normal. Utah Lake, sticking in the Great Basin, around 120% of normal. And then moving into the upper Colorado River Basin, so this area here, and working our way from north to south. So Flaming Gorge Reservoir in the upper green. So this encompasses southwest Wyoming, as well as the north slope of the Uinta range. So our ESP model guidance, the April through July volume from yesterday's run, around 90% of that 1991 through 2020 normal seasonal volume. The Colorado Cameo, so this is a good summary of the headwaters of the Colorado, pretty similar, right around 92% of average. And then as we work our way south into the Gunnison, Blue Mesa Reservoir, right around 85% of average. McPhee and Navajo, so McPhee's in the Dolores River Basin and Navajo is in the San Juan River Basin. Those 2 points around 65% of average. So, lower soil moisture conditions, lower snowpack conditions, corresponding to lower water supply outlook. And then in the lower Colorado River Basin, a couple locations in the Salt River Basin around Roosevelt Reservoir. The ESP model guidance from yesterday is 76% of median. So the forecast period down in the lower Colorado River Basin is a January through May forecast period, whereas the Great Basin and upper Colorado River Basin is an April through July period. San Carlos Reservoir, Upper Gila, around 88% of median. And looks like I skipped over Lake Powell. So Lake Powell summarizes the hydrologic conditions of the entire upper Colorado River Basin. So our hydrologic ESP model run from yesterday, sitting around 80% of average for Lake Powell. Now into the 7-day precipitation forecast. So the graphic on the left here showing the forecast precipitation today through next Wednesday, so the next 7 days. You can see most of the area not expecting any precipitation, but there is this moisture that's settling in over the San Juan Mountains today, tomorrow. So that area is expecting 6 to 12 inches of snow the next 24, 36 hours. So it should help the San Juan Basin improve their snowpack conditions. Beyond this storm today, tomorrow, we're expecting high pressure to settle in, and that will bring a warming and drying trend to our area into early next week, with temperatures 10 to 15 degrees above normal by this weekend. So looking out a little bit further, the 8 to 14 day outlook. So this would cover the December 20th through 26th period. These graphics are showing the probability of being above or below normal when it comes to temperature and precipitation. So temperature on the left here, warmer than normal temperatures expected across basically the entire US. And then on the right, the 8 to 14 day precip outlook, we are expecting or seeing increased chances for a storm system that would bring precipitation to much of the western US next week. So some good news on the way. Hopefully this verifies and we do get some of that moisture. Now into the El Nino Southern Oscillation, or ENSO status. So the Climate Prediction Center, their last update was a while ago, back on November 9th, so a little over a month ago. They'll probably come out with an update this week or next week, but there is currently an El Nino advisory, and El Nino is expected to continue through the spring. So what does that mean? Typically, it means increased chances of wetter winter weather in Arizona. It's not guaranteed, but that's happens more times than not when there's an El Nino. Elsewhere in the basin, there's a weaker correlation when it comes to winter weather and the El Nino pattern. So in the upper right here, in El Nino, and then expected to continue that through the spring. Currently, the models are showing transition towards more of a neutral ENSO status come late spring, early summer. And you can see there's a bunch of models that go into producing these probabilities. You can see how they are trending generally, kind of staying high for the next couple months, and then trending more towards neutral conditions. So over NOAAclimate.gov, they did an analysis here that I came across. Interesting graphics. So they looked at snowfall during all El Nino winters. So this would be the January through March period. And their analysis was over the entire North America, but just focusing in on our area of interest here. So their analysis, the graphic on the left, this is showing the difference from average snowfall during all El Ninos. So again, not really surprised to see that across central Arizona, but this analysis does show, in Utah, really over our entire forecast area, higher than average snowfall. That's on average. Again, we really don't know how it's going to play out. If you look at last year, we were in La Nina conditions, which typically means drier winter weather across Arizona, and we had an extremely wet winter last year during La Nina, which was unusual, but it's not out of the question. And then the number of years that had below average snowfall during a moderate or strong El Nino, shown on the graphic on the right. There's a link here if you want to look into this a little bit more. So into the seasonal outlook from the Climate Prediction Center. This is the December, January, February timeframe. They issued these forecasts back mid-November. So this would be the 3-month period when it comes to their outlook for the temperature on the left. So forecasting over most of the area, equal chances of above or below normal temperatures, and their precipitation outlook, slightly increased chances for above normal precipitation, and they have that up into Utah and across Colorado was their outlook that was issued about a month ago for the December through February timeframe. So to summarize, upper Colorado, soil moisture generally near to below normal, snowpack near to well below normal, and you can see how that translates into the current water supply outlook across the upper Colorado River Basin, generally near to well below normal volumes from our model run yesterday. In the lower Colorado River Basin, below normal soil moisture, well below normal snowpack, translating to below normal volume outlook currently. Great Basin, currently conditions when it comes to soil moisture and snowpack sitting better than the Colorado River Basin. You can see some of those blues and greens on the map on the right with near to above normal seasonal volumes expected right now. It's still early in the season. Again, so the weather forecast, San Juan's 6 to 12 inches of new snow today, tomorrow. Then we're going to be warm and dry into early next week with increased chances of precip next week. And the ENSO status, currently El Nino conditions, which generally means increased chances of wetter winter weather across Arizona. But again, it's not guaranteed by any means. So just taking a look now at when we're going to start issuing some forecast products. So our ESP model guidance, that's not yet on our webpage. We are hoping to have that up on our website by the end of this week, and we will start issuing official water supply forecasts starting in early January. And accompanying those is a CBRFC water supply briefing similar to this one. That's typically around the 5th working day of the month. And we also issue water supply discussions around the beginning of the month and the middle of the month that discuss current conditions and the water supply outlook. And then peak flow forecasts are available on our webpage beginning in early March. And those correspond to peak flows expected due to snowmelt runoff. So just reviewing our upcoming webinar schedule. So we have 2 webinars, one for the Colorado River Basin, one for Utah Great Basin. You can see the dates there. They're on the same day with the Colorado River Basin webinar at 10 a.m. and the Utah webinar at 11:30. And we do put on a peak flow forecast webinar. This year it's scheduled Wednesday, March 20th at 10 o'clock. This all is on our webpage, cbrfc.noaa.gov. Drop down this news drop down. There's webinars. We'll take you to this page here with links to register for the webinars. This presentations page, this is where this webinar is going to be posted, and you can find past webinars there as well. And we do have some email lists if you're interested in receiving additional information about when are water supply discussions out, or when are certain forecast products have been issued. And you can request to be on one of those through this link here. So this is how you can get in touch with us and the basin focal points for this water year. Not going to step through all of these. You can take a look to see who's forecasting your location of interest, how to get in touch with them. This is our CBRFC operations email and phone line are probably the best way to get in touch with us. 365 days a week. We're here typically 6:30 to about 3 or 4. So this is the best way to get in touch with us. We will be hiring soon. We'll have 3 job openings. So if you're interested, keep an eye out for those. And we'll keep you posted with our upcoming webinars on when those are available if you're interested. And that's all I had. I'll open it up to questions. Here we're just looking at, this is an animation showing that transition from La Nina to El Nino during 2023. So this is the area in the Pacific along the equator where the ENSO status is determined based on the sea surface temperature. So we are in La Nina earlier in the year, and then we transitioned to above normal temperatures there, and now we're in El Nino conditions. So stop there and take any questions if there are any. Well, I'm not seeing any or any hands raised. So with that, we'll end there and hope to see you in early January for an update. Thanks for attending.